Good evening, Professor Jai Singh. Good evening, everyone. So today, actually, as usual, we are going to start the lecture series. That is today's 14th one, the medium rise building design and construction. So today topic is a demonstration of three-dimensional computer modeling of strong elements. The lecture will be done by Professor M.T.R. Jai Singh. So I think I don't need to give any introduction, as everyone knows about you, very well aware. And so I will directly hand over the forum to you, sir, to conduct the lecture as usual today. Sir, over to you, sir.
Yeah. Prima, can you hear me now?
Yes, sir. We can hear you.
I'm just trying to see whether I'm using two devices today. What I do is I'll leave my phone and just to check whether you can hear me.
Okay.
Can you hear me now?
Yes, sir. We can hear you.
Then because last time the computer did not work, so I had to use my phone. But if I use only the computer, it's better for all of us. So now you can hear me?
Yes, yes.
I think sound is not that strong. I mean, very, very light.
If you can increase the volume, sir, that's...
Yeah, please.
Now you just try this one, right? I'll come on the phone and see whether it's clearer. Just one moment.
Recording in progress.
Can you hear me now?
Yeah, well.
Now it's better.
Better, right? Okay. It's better, right? Okay.
Yeah, now it's okay, sir.
But am I getting an echo? Right. Okay. Can you hear me now?
Yes.
Yes, yes.
No echo now. Right? Okay, now it's fine. I'm using my phone for audio and for video. I'm using the computer, right? Okay. So what I do is last time we started the problem, so today we'll go ahead with that. And can you see this SAP 2000 screen?
Yes, yes, we can see.
So what I do is first we'll change the units to kilonewton meters, and I'm going to do the modeling part today. Right? So, and I will explain the important points as we do the modeling. Right. So I'll start with a new model, and I will go for our building 2D frame. And number of stories, I'll go for one story first, and the number of bays 4, and number of bays in the y direction 4, floor to floor height 3.6 meters, and in x direction 7.5 meters, y direction 6 meters. And so I'll create this particular building. And the building looks like this. You can see the building. Yes. Okay, right. Because yeah. So basically, I mean, this is the building, and if you want, I can just show you the view at 3.6 meters. Right. So this is a building, and if you want, you can actually move the whole thing and bring it to the center. But I'll just keep it as it is because otherwise I have to change the grid location as well. So if you want to, I mean, sometimes it is preferable to have the grid starting at one of these places. But in this particular case, I will not really worry about it. The reason is, when you have the grid starting at the lowest corner, always you have positive. Otherwise, you have some negative, some positive, that can create some problems. But okay, so what we can do is, one option available is to select all and move by 15 this way x direction and 12 in the y direction. But the moment you do that, you will have to define the grid. Define the grid. Where's the grid? Yeah, grids. Global modify show the system, and here you start with 0 and then 7.5. So basically, rather than giving, you go for the spacing, and you say here also 7.5 and 7.5. Sorry, for not ordinate spacing. Here you change it to 7.5 each. I put it to spacing and see ordinates. Now you can see it starts from 0 and going up to 30. And I'll do the same thing for this one. Go to spacing and 0. 36. When you go to ordinates, I'll make it 0 and 6, 12, spacing. Right, now it's okay. So I'll say it's okay. Now you can see the grid has been adjusted. Now the grid has been adjusted and it goes A, B, C, D, E, A, and this way 1, 2, 3, 4, and the origin is at this point. So then the most important thing is, you have to define so many things. So materials, and I'll make a copy of the material, and I'll go for advanced property display, and I'll say concrete, and I'm going to have a beam concrete. And let's say I'll start with something like 30 megapascal concrete, but later you can change it. So I'll start with something like 30 megapascal concrete, and elastic modulus of 30 megapascal is 27 e to the power 6, and the unit weight is something like 25, and mass is 2.5, because Eurocode say the mass is density is 2.5, and the strength of the concrete is 30 megapascal. And we say okay, and okay. So basically we have one material, then add a copy of the material, concrete beam 30, and we say it's column concrete, column 30, concrete column 30, say okay. We have concrete beam 30, concrete column 30, and we have columns, beams, and add concrete wall 30. Wall 30. So we are having everything out of 30 megapascal. I think that day we did something that is okay. I say okay. Stop share. Right. Okay. Right. So basically, now we have got the define. Just one moment. Now this sub got stuck. Stop share. Just one moment. This sub got stuck. Stopped. Yes. Okay, Q2. Share the screen. So define. The materials have been okay. We have defined 3 materials. It's okay. And then define section properties, frame sections, and add a new property. And I'll go for concrete. And I'll add a rectangular section of column concrete, beam concrete 30. And I'll say beam 600 by 400. We'll not worry too much about it. Depth is 0.6 meters. Width is 0.4 meters. Then we can add another section, and that is column 1000 by 1000. And 1, 1. So beam 600 by 400, column 1000 by 1000. And generally, you know, I use, so that is okay, we say okay. And as we go, we'll define other things. And then frame sections, tendon sections, cable sections, area sections. And we'll say that we are going to use shell elements, add a new section, and we say wall. We say all the walls we are going to use 250 for the time being. And we say shell thin, it's okay. And we'll use wall concrete 30. The membrane and bending is 0.25, 0.25. I'll explain it later. The bending thickness is used to calculate the bending properties. Membrane thickness is used to calculate the membrane thickness and the weight of the structure. So when the program calculates the weight of the wall, it is based on the membrane thickness. Whereas when it's calculating the stiffness, it's based on the bending thickness. And in in addition to that, all these, you get something called set modifiers. You can modify the section, whatever the section you want, you can modify that also. So all these modern programs allow you to modify the sections. So we'll use that facility and we say okay. Right. Now we are in a situation where we want to allocate the column of 1000 millimeter by 1000 millimeter to all. So what I can do is here to allocate all that, I can go to view and go for a 3D view, and I can say, let's look at XY, generally make it 0. XY is, we are looking at the plan view. And we go to 3D view, and we go to XZ. Here you can see we are looking at an elevation, and I'll put this on 3D. You can see what's going on. And what I do is I select all the members like this. So all the members are selected, and now can assign a property for that. Assign a frame, section, and I will allocate it as columns. So it's all allocated as columns. And if you want, you can go there and extrude the view. Extrude the view. You can see everywhere column has been allocated, the beam is small. Beam is small. Then what you can do is, I'll change it back to the normal view. I'll not extrude it. Let's see the normal view. Then what I do is, I will also do a small trick. And I'll say assign. No, I don't really have to do that. What I do is I'll go other way. What I do is I will clear the selection. Now what happens? I have selected all the beams but not columns. So you can manipulate the mouse, and then you can select different things. And what I do is I'll assign the frame sections, and I'll make sure they're all beams. And you can extrude and see whether you have got it right. So what I got to do is I'll assign. So I'll view. Extrude the view. Right. Now you can see I got all the beams. Now what I do is I want to allocate the columns, walls, shear walls. So to allocate shear walls, there are a few locations where I don't need columns. So what I do is I'll go back to so basically I don't need a column here. I don't need a column there. Do not need a column there. And I will also not need a column here. So I'll delete those columns that I don't need. And now I'm trying to get this sorted out with the walls. So what I do is I'll view 2D. at this location. Now you can see the size of the beams all marked. What I do is I'll work out the shear wall arrangement. So I say replicate at 2.5. I'll replicate here. Split by minus 2.5. Well, now I have got two boundaries of the lift system. So what I do is I will divide all these members, select all these members and ask it to divide at the intersections. So divide frames, break at the intersection. So basically now I have divided the members and I should be able to extrude. I'll use it to replicate it at 0, -3. So now what I can do is stuck, I think. Just one moment, I am stuck again. Save changes. And it solves. So time I'm having a small problem with the SAP. Share the screen. Open. D1. Save as. In SAP, it's a good practice to save often. So what I do is I will select these points. All right. I have to divide this. Divide frames. And then what I do is I'll select these. Now what I do is I selected all. I'm going to extrude. Extrude lines to areas. And it asks a question. Delete the source object. I'll say don't delete it because sometimes I like these beams because you can't apply loads on wall. So what I generally do is I'll have an additional beam as a small section beam, so which can be primarily used for load transfer. Right. So what I do is it says property for added, so linear, and this 0 and minus 3.6 and once. Now you look at the right hand one to see what happens. Now you can see some walls have appeared and it's not very clear what are these walls mean. So we'll go to view and set display units. Extrude the view. I have extruded it. I'll say fill objects. Now can you see I have created the shear walls? But in an actual structure, you might have some other additional walls in the opening on the wall side. So you might have some small walls that will allow the fixing of the fixing of the lift doors. So basically, rather than a straight wall, you can have something like a return wall of about 600 millimeter or so. But I will ignore it because it will just take a little more time for me to create all that, and it's not really necessary because most of you know SAP, and I'm just trying to build it up so that you will be better. You'd be able to clear all your doubts, right? So now what I do is, so I need 2 more walls, so I'll just go there and say view and extrude, don't extrude. So now it's clear that we have one set of walls. So what I do is let's assume that here I can say replicate. And I'll say divide this. So what I do is I'll select this. There's one more column I have to get rid of. That is this column. I'll select this and this. Extrude. Lines to areas. Same thing. I extruded, so I don't need this particular member. Would I need it? Let's see. Yes. Before I divide it, I will divide it. I'll delete it, and if you need, we'll have it later. So you can see now we have got all the walls sorted out. And if I extrude the view here, now you can see the problem. These locations where you have the lift core, they are also having 600 by 400 beams. And why we need this 600? Some beam there is that, we like to apply the loads onto the walls. And because of that reason, we like to have a beam on the wall. The reason is SAP does not have a facility to apply the loads directly on the wall. So what we do is we define a wall. So we define a beam. So that means I have to go to properties. I'll save this as B3. Save. And what I do is I'll define a new property, but before defining the material, concrete additional beam. I'll apply a material and I'll show the properties. The same, but here I like it to be weightless. And here I like it to be massless. So basically I have made it a weightless material. Then what I do is I'll define a small section and add a copy of the property. See, I'll say additional beam 200 by 100. Very small beam. It's a small beam. And I'll have an additional beam. And what I do is I will assign, select these additional beams. Oh, it's stuck again. And just one moment, I'm just trying to get SketchUp back. It's open. Right. So what I'll do is I'll add these. So I'll assign now you can see now we have got rid of those additional beams which are actually not there, and we have put a small beam just to apply the loads. Whereas you can see in the front and all that we are having some beams, and some of these beams may not be of this size because they are part of the core. And also we have to do the same thing here. Assign assign frame sections and yeah, okay. Right, so I have made the beam section smaller at all the locations that I'm having the walls, and basically we put a beam to assure that the loads have been properly applied. Because always it's easier to apply loads on the beams. And if the beams are having proper connectivity, you'll find all the loads can be easily transferred. Sorry. And in addition to that, you can see now here you might get another beam, not 600 by 400. So because of that, we'll define section properties. And I'll add a copy of the property, and it will be beam 600. I'll say 1000 by 250. So that is 1.25. So I'll say okay there, and I'll change this, and I'll say assign frame sections 1000 by 250. Now can you see, because those beams have become deeper. The reason is, on the front of the floor to floor height of 3.6 meters. So the front side opening can be anything from 2.4 meters. Around 2.4 meters, and above that will be the wall. So I have selected just 1 meter by 250. But even in a real project, you can always calculate what is if you know the size of the lift wall and the lift height, the opening height, So you can easily work out the depth of the beam that you can get at those locations. So now the first step is almost over. So I'll save it as B4, because there's a tendency today for my program to crash, get stuck once in a while. So until I get it checked, I will always, anyway, it's a good practice in SAP to check, save. As much as possible, because sometimes, it crashes. Right, so now the first step is over. And so now we have to apply the loads. Before we apply loads, we see what we are going to do about the steps. The steps. And there are two purposes that the steps will perform. One is, it will allow us to have all the vertical loads arrange as we want, because we have a slab. So secondly, we have to make sure that the correct mass is represented by the slabs. And we don't want any weight in the slabs, because we are going to apply the loads using the unit load method. And when you apply use the unit load method, you can easily work out the effect of self-weight. And the other main problem is when you use shell elements to represent the presence of the slab, they are actually connected only at the four corners. So I'll show you with an example what I'm trying to say. For that, I'll define material, and I'll add, add a copy of the material. I'll switch to the display. So what I want is, I do not want a weight. So I'll make the weight 0.001. And I'll keep the mass. And we call it slab concrete. Slab. I'll say 200 millimeter slab, 150, 160, 170 millimeter slab. And I'll say okay. And the difference between this material and the other materials is, here we can see 170 millimeter thick slab. And here you can see it's weightless, but it has a mass. So the mass is corresponding to the density, that is 2.5 tons per meter cubed. So we have all the information we need. So now I'll show you what I'm going to do. Okay. I'm going to add now I'm going to add a slab. And what I do is I'll use edit. Oh, it's got stuck again. stuck again. Yes. Okay. And then I will start SAP again. Share screen. Open it. And then what I do is I'll draw the slabs. For that. And I'll assign we are not defined a slab, so we have defined slab. Define section properties, area sections, and we'll add a new section. Slab 170. Thin section, and then we are going to use slab concrete. With this. Okay. And when you go for drawing, and 70. Okay, so when you draw the slab like that, we have got the correct mass, but you know, it is connected only at the four points. It has connected here, connected here, connected here, connected here. So because it's connected only at the four corners, we don't use it for anything. Any load France or anything, we don't use it. We draw the slab due to two reasons. One is when you have a slab, we don't have to define a rigid, it has a rigid diaphragm. Because automatically it will take it as a rigid diaphragm. But on the other hand, so right, what I want to say is, you know, if you have the slab, indicate it, then it will act as a rigid diaphragm. On the other hand, you can actually define a rigid diaphragm at each floor. There are two options. One is actually representing the slab so that the deformations the in-plane deformations can be reduced. And it will act like a rigid diaphragm. But on the other hand, you can most of the programs carry the option that you can define it as a rigid diaphragm. So, but in my case, I'll use this one. Okay, we have all the slabs, and we also have to draw slab there. Now you can see the flows all arranged. A rigid diaphragm action is now available. Right. So now we have one flow almost done. So I'll save it. Save as P5. Save it. Now I would like to apply some loads. See, in all these areas, I will apply unit load 1, and only these two small areas I'll apply unit load 2. Right. So I'll define a load pattern. Unit load 1. And we have to say it's not a dead load. The new load pattern. I'll say okay. Right. Now what I'm going to do is I will see how the loads can be applied. And so I'll select this beam. I'll first show you how the load can be applied. And I can define load pattern. And then what I do is I'll assign, select these frames. And because these are identical, I select this side also. Now what I do is I'll assign frame loads, distributed, unit load 1, so you'll get a situation where you can actually go for absolute distance from edge, and the actual distances will be 0, 0. At the end of 3 meters, you are going to get 3 Yes, on the 3 meters 3. And at the end of 4.5 meters, so I'll ask this to view. And I'll say display. Stop share. Open P5, and then I'll share the screen. Display. Okay. There's a small mistake that I have made, and I have to apply loads. Assign frame loads, distributed, unit load 1. Also go for the absolute distances. 0, very 0, 0. When it is 3 meters 3, 4.5 meters, again 3, and then at 6 meter, at 7.5 meters, it becomes 0. There you are. Now it's okay. So similarly, you have to apply loads at all the other members. These members, okay. And these members are also internal members. So now I can apply the loads, but here you can see the loads are coming from both sides. So then when I assign frame loads, distributed, unit load 1, the amplitude is 6, here 6. Similarly, you have to apply loads on all the members. And if you look at the other direction, and I'll say assign frame loads distributed 3, magnitude is 3, and at 6, the magnitude is 0. This is 0. Right, now we can see the loads. And then on these ones also we can apply the loads. And here you get it. Yes, here also you get it. Right. Now I will apply assign distributed. And here you get 6. Similarly, you have to apply loads carefully onto these areas also. So some of these areas, the loads are missing. And I'll show you one place where this can be done. And that is this place. So I want to apply loads here. What I do is I'll join them. Now here you can see one member, and then I can assign frame loads distributed. The same thing as before. Oh no, it's wrong. Assign 3, 4.5 and 7.5. Now you can see it's applied, but I like to see the breakage there. So what I do is I'll mark this one. Sorry, no. What I do is I'll this one. And if I divide lines, now you can see automatically it's divided. And the loading is automatic, but you can see there's a division, so it's all clearly indicated here, right? So basically you have to apply the loads on all the other members similarly, and let's assume that we apply the loads. And so unit load 1 is okay. So what you can say is, let's assume that this is all designed as one-way slab. So now what I'll do is I'll apply. So this kind of one-way span is slab because it's a small span. So what I can do is I'll simply consider it's one-way spanning, and then I will apply unit load 2. So for that I have defined a load pattern called unit load 2. We have already defined it. So what I do is I will consider that it's one-way spanning, and then I will assign. Oh, it's stuck again. Save. Stop share. Share the screen. All right, okay. Then open. It's done. And then I select these members. And assign frame loads distributed unit load 2, and I can say it's a uniform load of the passage is 2.5 meters wide, so I can say 1.2. But the important thing is this is unit load 2. Now you can see whether it's displayed. Answer is it doesn't display, so what I have to do is there you are. So basically now we have two sets of loads, unit load 1, unit load 2. Then what you do is you are define load cases, not load cases. You can design the load combinations. And We'll first say slab dead 1. Now we are going to define the self weight of the slab. Linear unit load 1. You apply a unit load 1. So if you apply unit, what is the thickness of the slab? 170 millimeters. So what is the unit load 1? And unit load 1 is one is 170 0.17 multiplied by 25 and that is 4.25 meters kilonewtons per meter square. So we multiplied by 4.2 and add it. Okay. And similarly, we define and this time it comes with unit load number 2. Let's say the slab thickness there is 200 millimeters, so you multiply it by 5. And similarly, we are define the partition loads, finishers. So what we do is we can define a load combination, and we can also have slab finishers, and then it will be unit load 1 multiplied by the finishers value. Let's say the finishers value with all the finishers, and we'll come to about 1. So basically, and just keep it. And unit load 2 also 1. You can keep it. And then we get slab partitions. Let's say we are going to allocate 1.5 and add new combo. And you can say slab partitions. And unit load 1. Load 2. 1. And let's say the slab partitions we are going to use 1.5. Modified. And load 2, you're going to add it. So this will be there. And then add the new combo slab live. Slab live. Let's say this is an office building and we are designing it for 2.5 live load. Right. And we say okay. And we say okay. Now we can define a new load combination. And let's say we are going to have a load combination. I'll just demonstrate one. That is 1.35 GK plus 1.4, 1.5 QK. So let's say it's combination 4. So dead loads will be there because the dead loads will come only from the weight of the columns and the beams. And we have to multiply all the dead loads by 1.35. Get it. Then we have slab dead multiplied by 1.35. Add slab dead 2, add, and slab partitions, add, finishers, add, and slab live, you have to multiply it by 1.5. Okay. So combination 4 is, all the dead loads and vertical loads only, and I will not consider wing loads, but, I just want to demonstrate how you deal with it. And I'll say save as QB6. Save, and I'll save as, stuck again. Share the screen. You can see the screen and open the file. And then I will save as 7. And I'll go for the 3D view. Yes, okay. And I can select all. Select all. Replicate. At 3.6. And say 50 times. I can create a display undeformed shape. I'll say view, fill objects. Okay. So basically, the whole process is we carefully apply all the loads and create the combinations. And once you do everything properly at each flow level, you can easily create a model by replicating it. And you can, so you can have a building model like this. And once you model it, you can ask it to analyze it. And so you can see all the different load combinations, places are there. And you can ask it to analyze. Unfortunately, again, it's this. So, yes, save changes, yes. And open it again. Stop share. Share the screen, share. Open. And then I'll ask it to analyze it. There is something more. Stuck. It's stuck. So basically, after you do all this, you can analyze and get some results. But the important point is, you have to carefully apply the loads on the beams. And you can also go for different slab thicknesses by defining different unit loads. And also this is one of the methods that you can use for applying the loads. But some programs allow you to apply the loads with the magnitude directly. And my experience is, this method also can work pretty well. And I think for large buildings like Altea, I think I use this method. But it's all up to you, and also depends on the software that you use. So basically, the important thing is, you have to get these members sorted out properly. And then we'll see whether it analyzes, because there's something wrong. It's not analyzing. I stuck. So basically, I have shown you the process, but once you do that, you can analyze it. But I think it's some small problem with the program. I had to get it checked. So I'll stop it. And so basically, what I wanted to highlight was that, if you think carefully and then, do a step-by-step analysis, and always think, how the codes say, when you apply loads onto the beams, so onto the slabs, those loads will be transferred onto the beams. Via the beams, the loads will be transferred onto the columns. So if you get the loads properly applied onto the beams, then the rest is okay, because the beams will automatically transfer the loads onto the columns. So the most important thing is, whatever the method you use, make sure the loads transferred onto the beams will represent the actual situation that you can expect in the real structure. So always check the program to make sure that the loads applied are properly done, so that the final result that you get out of this 3D model would be the loads acting on the columns. And those are the ones that you use for design. So the proper load transfer should start by getting the loads on the beams as proper ones. And it can be different methods, but always check and see whether the loads on the beams represent the real situation. And with that, shall I conclude the lecture, Thima?
Yeah.
Yes, sir. Yes.
Okay, right. So basically, I showed the basic method, and what I wanted to highlight was, why you should be careful in applying the loads. That's number one, and how you can get the strong elements like shear walls, so that your model will be a real accurate representation of the real structure. Right? So in 3D model, we know our structures might look pretty similar to the real structure. But the most important thing is getting the behavior right. So to get the behavior right, you have to get all the strong elements right. And once you have all the strong elements, you have to get the loads right. And then you are reasonably sure of the answers that you are getting as correct. So never assume anything, but always apply the loads in a logical manner and check whether the loads applied are reasonably represented. And once you do that, the chances of getting a wrong answer from a model will be very remote chance. So that's what I wanted to highlight. So with that, Trima, we'll conclude the lecture, right?
Okay. Okay, sir. Right. So I will invite Engineer Sugantalingam to give vote of thanks. Engineer Sugantalingam, over to you.
Good evening to everybody. It is such an honor for me to get this opportunity to thanking you all on behalf of the Civil Engineering Sectional Committee. Thank you very much, Professor Pisanji Singh, for your continuous informative presentation.
Yeah.
You are all.
Yeah, actually, there's a small thing. Can you give me about 1 minute? There are few questions posted on the chat, and it says, please keep the right. Okay. Do we need to model staircase is available? So generally, I mean, you don't have to model the staircase unless it's going to contribute to the lateral load resistance. What is the main difference between BS code and Eurocode? Actually, Eurocodes are much more accurate and they give a lot of freedom to the designer. So you can get really economical designs done. Can you show how you built 50 floors in SAP model? Once again, final part only, I think, it's just a replication. So basically what you do is you will go and select all the members that you want to replicate and then ask it to replicate up to whatever the number of floors. So I will show it again. Can you apply area loads on slab panels? Yes, some programs allow it. One example is ETAPS. It has allowed you to apply the loads on the slabs. And then what it says is, while analyzing, it will divide the slab into small areas. And then, such that ETAPS can get a reasonably accurate load transfer. And MIDAS is slightly different. MIDAS is like this one. In MIDAS, when you select the loads on the slabs will automatically be converted to this particular format. So the different programs work differently, but SAP do not apply loads on the slabs because, slabs are not properly represented in SAP 2000. So if you try to apply loads on the slabs, then you have to do a lot of things like breaking the slabs into small pieces and then also dividing the beams also to the same size. Those are very cumbersome things and the models become extremely heavy. And then the models will take a lot of time to analyze. But my perception is because we are needing only a reasonable answer, our models need not be too complicated. If you do a simple load transfer onto the beams and then do the analysis, then the model is very light and it can give the answers very fast. so that you can go to the next step of designing very fast. So I always prefer simple load transfers, and then getting the answers directly, and then checking those answers by using a suitable means. But if you are free to do anything, but the most important thing is whatever the software you use, go through the manuals and see how it has the people who have written it has seen it. And once you are sure that whatever the answer you get is closely resemble the real situation, then you are assured of a good answer. Never just assume that program is going to one thing or the other, because programs can be doing so many different things differently, and the same program might offer so many different options as well. So always when you are using a software, always talk with the person who is very familiar with that software, and ask you questions, and you might get good answers. And if you think that that person looks knowledgeable with your experience, then keep on asking. Otherwise, if the person is also not sure, then don't ask that person, because he would have just learned to use it without understanding how it works. So the most important thing is try and understand how the author of the software has written this. And once you understand it, then you can take better control of your models. So with that, please go ahead with the conclusion. Yeah, please go ahead.
Thank you very much, Professor Pisanji Singer, for your continuous informative presentation. You are always to share your knowledge as the chairman of the Civil Engineering Sectional Committee. You are doing remarkable job. Dear sir, you are encouraging our engineers and motivate them for CPD activities. Thank you very much again, sir.
Okay, thank you very much.
Special thanks go to Engineer Kamala Gunavaddana, member of Civil Engineering Sectional Committee and chairperson of the Knowledge Sharing Subcommittee, for getting the webinar arrangement successfully for this event. Then my sincere thanks go to IESL Secretary and then IT team for publicity and hosting arrangement. Last but not least, I thank you all for your active participation. And without we can't make the event successfully. We expect your active participation for upcoming event too. Have a wonderful evening to you all. Thank you.
Okay, thank you very much.
Well done.
Okay, thank you.
Okay, sir. Good night, everyone.
Thank you very much, Professor. Thank you.
Thank
Good
you.
night.
Thank you.
Good night, Rima. Everyone, good night.
Good night. Good night.